So you have seen Xamarin Forms in action. And you know that with Xamarin Forms, you can build native apps for different platforms. But you might be curious how Xamarin actually achieves this. So let me give you a bit of background. All Xamarin products, like Xamarin.Android, Xamarin.iOS, and Xamarin Forms, are built on top of Mono, which is an open source version of .NET that runs on various non-Windows platforms, like Linux, Unix, and OS X. Mono is a project that has been around since pretty much as long as .NET itself, but it wasn't very popular until recent years. In the Mono world, we had two releases. One was called Mono for Android, which was later renamed to Xamarin.Android, and the other release was Mono Touch, which is now what we call Xamarin.iOS. Both these libraries give you access to the .NET base class library. So you have the same namespaces you are familiar with. You got the same classes with the same interfaces, but they also give you access to the native API on their platform. So you have access to additional assemblies and namespaces that mimic the ones that come natively with Android and iOS. These are the classes that Objective-C or Java developers work with when they build native apps for Android and iOS. When using Xamarin.Android or Xamarin.iOS, we work with these classes just like standard C# classes in .NET. And these libraries will internally call the corresponding API on the target platform. Now, how that happens, it's pretty complex and it's not something we need to worry about. That's something that developers at Xamarin have to deal with. Now that you have an understanding of Xamarin.Android and Xamarin.iOS, let's get a little bit more specific here. When you build an application with Xamarin.Android, Xamarin C# compiler compiles down your C# code to intermediate language or IL. It also embeds the Mono runtime with your application. This Mono runtime is similar to CLR that you should probably be familiar with. So when you launch an Android app, this runtime is loaded into the memory, and then it gets your IL code and compiles it to the native code for Android. And this process is what we call just-in-time compilation or JIT. This is the same mechanism that is in place when you build a regular .NET application with C#. When you build a console, desktop, or web application, the same magic happens. Now with iOS, we have a different story. Apple does not allow JITting. So when you build your iOS application, Xamarin C# compiler first compiles your C# code down to IL, and then it uses Apple compiler to compile it to native code. And that's why you need an Apple machine. So the output is native code that iOS can understand, and there is no JITting involved here. In other words, when you ship your application, there is no Mono runtime embedded in your application. So this is how Xamarin.Android and Xamarin.iOS work. But what about Xamarin Forms? Well, Xamarin Forms is built on top of these two libraries. So we have this assembly called xamarin.forms.core, and here we have classes that define a common unified API to work with different platforms. For example, we have a class called button, and this is the button that we reference in XAML or in code behind. Now, we have another bunch of platform-specific assemblies that map these common objects in Xamarin Forms to their corresponding native equivalent. Let me show you. So here in this blank solution, let's expand this portable class library. Now, under references, under from packages, look, we've got xamarin.forms.core. And this is the assembly that defines that common API that we work with. So here we've got classes like button, label, list view, page, and so on. Now, if you look at one of the platform-specific projects, like the Android one, again under references, from packages. Now here we have an assembly called xamarin.forms.platform.android. And this is the assembly that is responsible for mapping those common controls we have in xamarin.forms.core into their corresponding Android equivalent. And in this assembly, we have a bunch of what we call renderers. So these are the classes that know how to render, for example, a label or a button. Now we have the same architecture in other projects. So let's expand the iOS project, references, from packages. Now look, we've got xamarin.forms.platform.ios. So this is how Xamarin Forms works.